For this week 6 activity on good design and poor design features, I'm reviewing the online learning environment known as PhET. PhET is a site for interactive simulations for science. It includes fields such as physics, biology, chemistry, earth sciences, as well as math. The name PhET itself, PhET, was originally an acronym for Physics Education Technology, but as you can see, it has expanded beyond physics. The simulations were developed at the University of Colorado Boulder, which is where they are still housed and maintained. This website provides an opportunity for students to engage in scientific inquiry, which is why I chose this for research this week, because it's one area of concern I have related to teaching science in an online environment. PhET simulations are developed using the following design principles. Let's see. Teaching resources. It appears somewhere. It talked about that it is designed around inquiry, scientific inquiry, to be encouraged by students. It provides interactivity for students. It makes the invisible world visible. So, for example, we could go to chemistry and study the alpha decay of particles that we otherwise would not be able to see. So we get visual mental models, and there are multiple representations. So as you work through, I didn't download it in advance. As you work through one of the PhET activities, you would get graphs, you would collect data, and they are authentic, real-world scenarios that the students get to work through. The scenarios themselves allow students to explore, but it also provides implicit guidance by limiting controls at different points to help their exploration become more productive. The simulations themselves are designed for use in all educational situations, formal and informal. They're accessible for elementary, middle school, high school, as well as at the university level, which is what they were initially designed for. Other effective design features that are found in PhET, as I mentioned earlier, inquiry is very important. The simulations themselves are free to anybody who wants to use them. They are open source. Let's get into... they're written using Java, Flash, and HTML5. So they can be run online. They can be downloaded to the computer, as you just saw me unintentionally download one. Or you can grab the code. I think you have to do individual sims here. So we can go in here, there we go, we can grab the embed code, and you can embed it into any online course platform such as Canvas or Moodle that you want your students to interact with in PhET, one of the PhET simulations. There are several tools in the simulations that make this an interactive experience for students. It might be a click and drag, finding points on a graph, or sliders to increase and decrease parameters. There's radio buttons on some of them where they can click on the particular button for a particular option. Students are able to make the measurements with different instruments that are simulated for them, such as rulers, stopwatches, voltmeters, thermometers. And as they're doing their work, the students are getting immediate feedback about the changes that they make, which encourages them to do further investigation and develop hypotheses about the relationships, cause and effect relationships to the variables that they're manipulating. The PhET environment as a whole is a safe area that students can explore these simulations in, that they can explore science in without any safety issues. This site also includes teaching resources that teachers who use PhET are able to share. There's where you can share your activities, and I didn't sign in. How do I get out of here now? There we go. Can sign in. Oh, I guess that just takes me back there. Oh boy, too many passwords. Is this the right one? Yay me. So it allows you to, if you're logged in, you can choose which simulation you are using, and there are several hundred simulations currently, with more being developed. You can upload files related to the simulation, so it may be handouts, and then you grant permission for others to use it. You can browse the activities that others have loaded. Here you can choose from what subjects you want, what levels you're looking for, even different languages. So many of the activities and the simulations themselves have been translated into multiple languages. So PhET, which I have used in the past, the more I dig into it, the more impressed I am with it and its potential to help with teaching online science. Some ineffective or poor development issues with PhET is that the feedback they get is programmed feedback, so it's not direct feedback from the teachers. That's not included in this website, but as I mentioned, you can embed the code into your online course and provide feedback that way. Having these as individual standalone activities can be a source of isolation for students instead of the social aspect of learning that would be preferred. But again, you can design around that by having students work with specific partners or groups. Something that is difficult to work around is the limited support that's available. So you can see there is donation requests right on here. Help Center, source codes. Where's the donation button? Well, there we go, donation. They aren't that well supported, obviously, because it's free. And along with that, it was initially designed around Flash, which was state of the art 15 plus years ago when this project first started. And now you can't run Flash on many computers, on tablets, So these simulations have to be revamped so that they can run on HTML5. So they're trying to rewrite the code to make them work that way. There's also no easy grading program, which, again, you can simply upload the code into your online course to make it work. Overall, I had almost forgotten about PhET and how useful it was the few times I have used it. And if I do, as I do, when I do develop more online science courses, I will make sure to get more use out of PhET.